Okay, so in this small video, I will walk you through a tutorial on how to run one of the programs. I will be using one of the programs I covered lately in class. Okay, so we open MPLab X IDE. We don't open the IPE. We're not going to be using it. So we open that. Wait for a second. And we're greeted with this particular page. Okay. So this particular page, we've seen it during the setup and the installation. So yours might open in the Learn and Discover. If it does, you're just gonna have to go to the My MPLab X IDE, the one here. Okay, and then from here we can actually create a new project. These are like you can open a sample or open a previous project or whatnot. We're gonna create a new project. So this project where we are actually asked what type of project we have. We have like a standalone project because it's brand new, it's blank. Okay, from here also we're asked to decide what device, what microcontroller we're actually using. We are using the PIC 18F4321. So we're gonna activate this. So from the tools, we're gonna activate the simulator. If you forget, later on you will be asked to actually run it, because today we're not going to be actually placing anything on a microcontroller itself. What we're going to be doing is we're going to do it within the MPLab, and we're going to see what's happening in memory, and that all happens within a simulator. So we're going to activate that simulator. We're going to click next, and you can see that we're going through these steps, and because we are not programming the device, okay, it jumped over the header and the plugin board and whatnot. So from here we're asked what compiler or assembler we do need to work with. If we were writing C code, which we are not today, we would have selected the XC8. That's the other compiler that we installed, or the standalone compiler that we actually installed, the one that worked with 8-bit microcontrollers. What we're going to be doing today is the PIC AS, which stands for assembly, for PIC assembly. We're going to click next, and then you can name the project whatever you like. Now this is a very important comment in here. Your path, wherever you put your project, whatever you name it, your path from the beginning to the name of the project should not have a space in it. So frankly speaking, I've included I've done some projects here in MPLab X IDE, and I created this particular directory under my C drive, and then here I can actually use whatever name I want. For example, this is first tutorial okay. Initially I think it was within my home directory, within my name, and my name actually has it with my last name. It's somewhere here, I don't know, it's like it was somewhere in that directory, and that directory has my name, and my name has spaces in it. Your program is not going to work. It's not going to like it. The compiler is not going to be able to compile that. So it's very important that you make sure that the total path that you have, this is the path for your project, should not have any spaces in it. Okay, and here you have a bunch of check marks you can actually check or not check. Set as main project. Basically, if you open MPLab X IDE next time, you will see this project. This is up to you whether you want to keep it or not. Use project location as a project. So this is a location I'm keeping all my project within it. And whenever I say, for example, first tutorial, it's going to create a new directory inside it. Okay, and inside that new directory, it's going to create every file we use. If you actually check on this, it will use this as where the directory, the target directory for us to actually, so you're going to see just scrambled all sorts of files in here. But I prefer to do it this way. I'm going to keep all the projects separately within their own directories and folders. So I'm just going to keep it that way. You can leave the encoding as is. We click finish, and now we're here. So you're going to see this is actually another project that I have, so I'm going to try to actually remove it. I think I can do that, and then I'm going to remove this. So it got removed. Okay. Your window might seem a little bit different. I just basically close everything, but it might have looks something like this. So your projects would be here on the top. You might have seen the dashboard, which I'll actually click here. You're going to see that dashboard in here. And then I'm going to see, I think, the navigator. I don't need the navigator for now. So this is what I have in front of me. So here is also the files. I'm going to click on the files, and I'm going to do that. So I have the projects and I have the files. So, okay. So this is just a tutorial of what's happening actually from MPLab X IDE. So the X IDE is actually based on NetBeans. If you have used it for C, wherever you actually learn C, some people actually use it. It's NetBeans IDE. That's not very important, but if you have used it, this interface is very familiar to you. Anyway, so we go back in here. This is the project we have created. It's a blank project, but it has certain subdirectory inside it or subfolders. So I have header file, something imported, which we have a make file. It's by default. This is the one that was going to compile our code. We have linker files, nothing in it. Source files, nothing in it. Libraries and loadables. So nothing in that project except for the make file. So this project in here also, you can see actually the files within it, and you can see that there's a bunch of files. So the files are different than the projects. So you might have files not included in the project. So and if you remove a file from the project, it still exists within the directory. Basically, if I go to that directory I created, which was in my C, so this is the C here, and I go to MPLab X IDE and I just say first tutorial. Basically, I'm here. I'm just exploring what's happening in here. This is the NP. So they are the same project. So if you don't want to do this in the Windows Explorer, whatever they call it nowadays, you basically just go in here and remove files from here if you wanted to. Okay, so here's that. This one here, which is basically the dashboard, that's what's it called. It gives you all sorts of information about the setup of your project, for example, which pick you're using, which compiler you're using, and so forth. And also later on, you're going to see that it tells you, once you put it on the microcontroller, the data. For example, it tells me that you have 512 bytes, and the program memory is, as we have seen, it's about 8 kilobytes or 4 kilo words. Okay, and it tells me the location and whatnot. So it gives me a bunch of information. Frankly speaking, I find this little button here is the most useful. Sometimes I set up a project property by mistake and I want to change it midway after I created the project. So I click in here and I can actually change whatever I want. For example, it's opened here on the conf, which is the configuration, and it tells me which compiler you want to use for this project. For example, let's assume that I set it up for the assembly, or by mistake, what you did is you clicked on the XC8, which actually is mainly used for C. We're going to see this later, but for today we're just going to be using the pick AS. Well, I don't know if the project would run if you selected the XC8. I'll have to try it. But anyway, if you wanted to change it, here's a place to change it. I'm just going to keep it in here. I'll click apply and I'll click OK. All right, even I forgot to say, like, even if by mistake you selected the wrong device, you can actually activate or select a different device from here. Let's assume that you changed your mind, you want to develop for a different microcontroller. You can just basically type its name here and click OK, and that will be there. Okay, so that's that. And now what we're going to be doing is I'll be putting that small assembly program we have discovered, the one that talks about indirect memory addressing mode, indirect addressing modes. So I'm going to go to the source files in here because it is a source file. So I'm going to click, right click on it. I'm going to click new. You're not, frankly speaking, when you first start, you're going to see that it's going to be C in here. All the stuff you're going to see is C. You're not going to see the assembly. I have been using it for a few days on this computer, so I started seeing assembly. So if you don't have the assembly, what you need to do is you go to other, and then from other it tells you what type of source file you want. We're going to go to the assembler because we're writing assembly. So if you're following older MPLab, so some of you are not with me in this lab, you're actually using a different IDE. I'll be using the X IDE, the older version. In the older version, you would have had to use the assembly.asm files in this IDE, and for this particular compiler, which is the XC8 in this current version as of today, which is June 12th, 2020, what you need to do is you need to select a file that is the .s. It's very important that you select the .s. If you select something else, it's not going to work. So click next, and then we can name that file whatever we want to name. For example, I can call it indirect addressing example. Okay. And of course, you're going to see that it's a .s. Again, no spaces in here. If you have any space, it's going to break the compiler and the assembler. Okay, we click finish, and there you go. So we are greeted with this editor window. It's basically, this is the file that we created. We can double click on it if you didn't see it. This is the start page. Here it is. and now you can create, or you can write your code. So I'm going to copy paste my code. The code looks a little bit different than the slides I've actually showed you. The main idea is pretty much the same number and everything. I just added a few flags. We're going to be talking about them later. These flags were optional in the old assembler, but it turns out to be with the XC8. You have to specify certain things with these flags. These flags mainly tell it, I actually forgot what the flag is, but let me just think about it. Yes, now I remember. This actually tells it that we are using this address as part of the access bank or the access RAM. It's that smaller version, the one that we don't have to use the BSR, the bank select register. So if you, it used to be by default OK selected if you don't specify anything. That command, that address in here, the one that you see, it's basically that's the part of the access register or access bank, okay? But now in this XC8, for some reason, it just needs it to be specified. We're going to be talking more about it, but anything you see in the datasheet or the or actually the book, it does not conform to this, and this is just a new thing by XC8, and they didn't bother. Microchip did not bother to actually update the datasheet to tell us that. So there will be a little bit of glitches here now and then when we're writing assembly code. I'll try to alert you to these changes or something like that. All right, and the other thing is this is with the psect code. This is also new. It's actually a preambler for the assembler. We'll be talking about it later. And anyway, so this is the code, and if you guys remember, it does move certain things within memory, or actually it clears a few places in memory. I think with 3 locations in memory, and that's what we're going to be doing today. So I'm gonna build this. You can build it or you can debug it. So let's build it just to make sure that it actually works. So I'm gonna build it. So when you click on the build, you're gonna see the output. So if you have any errors or anything, if you're not writing this particular exact code in here and you change something or there's an error, you're going to see it in here. So luckily for us, I spent about a day just cleaning up all the errors and all the warnings we have from this particular small code, and this is why you see these little tiny changes here and there. There's like a semicolon in here. It wasn't part of the code before, but it is now. Okay, so now I get a build successful. So the build was successful. All right. So, but what do I do with this? Well, you can now take it, like if we had a microcontroller connected, use N with a picket, and I'm going to show you how we do this in a couple of weeks or so. You can actually download that code into the microcontroller and just start your code. But for today, what we'll be doing is we're actually going to go to the debug main menu, okay, and we're going to see what's happening inside memory. So before I do, what I want to show you is you can actually go to Window, and from the window, you can actually go to the where is it? It's somewhere here. There you go, target memory views, and you can actually view certain things. For example, let's assume that you want to see the program memory. Okay, so we can see the program memory. Program memory is actually, yeah, the program memory, the same program memory we've been talking about. This is why I have spent so much time talking about program memory, because I want you to know what's happening. So here's the program memory, and as you can see, this is actually our code. It's coded in it. So the program memory, this is our assembly, and it gets to translate it. We're going to be talking about it in the coming week. It translates to some sort of numbers, because remember, it's like microcontrollers, you can only store bits of ones and zeros in it. So all these commands gets translated to ones and zeros, and that's basically it. Doesn't matter for today. What matters for today is what's happening in here. So I can see the program memory, and other stuff that I can see. We can actually go to there you go. We can see all the special function registers, the content of all of them. So the table that I've showed you, the special function registers and their addresses, it's actually here because you have selected that PIC18F as your family. So we're going to see those here, and we can see their content in hexadecimal, in decimal, and in binary, and in character, in case you're actually just storing characters in these locations. Okay, so these are the special function registers. And it turns out to be that we can also go and see the whole program, not the program memory, the file register. The file register is basically my data memory. Okay, so here's my data memory. It's a little bit, it's arranged in a little bit of a strange way, but as you can see, these are the starting addresses. So you're going to see this is bank, this is 000. And if you want 001, you're going to have to go in here and in here and in here. Basically, they're putting every 15 rows right next to each other. These are all in hex, okay? And this one here is basically the first 15 or 16 basically, because it goes from 0 all the way to F. Okay, so these are the first 16 rows, these are the second 16 rows, and so forth. And you can see that these are all part of bank 0 because I start with 0. And then for memory bank 1, they're going to be all in here. And as you guys remember, bank 2 and forward are not used. So this is why it's grayed out in here, because we know actually I can't scroll more anymore because the simulator knew that it's not implemented. So this is the program memory. So now it's all zeros. What I'm going to do is I'm going to go manually and put some sort of data in it, because this code supposedly clears it out. So the simulator already start with a cleared version of it. So what I'm going to do is I'm going to go manually in here and I'm going to change them. Okay, so we're going to go in here, for example, I know that 02, let me just see, it's not allowing me to edit. Okay. I think I need to run it. Let me just test it. So we're going to go to debug in here. We're going to click this debug. Okay, so this debug here, we created it. I think everything is running right now. So I'm going to pause it for a second. So we're going to pause. And now I'm just going to rearrange everything around me so that we can see all of them. So I'm going to see where's my program memory. Here's my program memory. So what I'm going to do is I'm going to drag it and just put it right next to the program itself, which we know where it is. Okay, so this is interesting. Look, so the arrow tells me we are in here, there's no operations, so nothing is actually happening. For some reason, it's either I'm too slow in pausing it, or it's just jumping there in the simulator. So what I'm going to do is I'm going to click this little 2 arrows in here, and this basically, if you hover over it, it tells you reset. So resetting, and you can see that I resetted the program counter to 000. Interestingly enough, you can actually see the content of the program counter right here on the top, and you can also see the status register and the working directory and which bank you're working on. These are really interesting locations. You can actually just see them right away. So when I clicked that reset, it put in the program counter 00. So it went to the first row in the program counter, which happened to be here. So that move LW03, that's basically the first row in my program. This is not part of the program. This just tells the assembler to do something. All right. Now I'm gonna keep the special function registers in here. I'll just make them a little bit bigger here, and I'm gonna take that file register and I'm gonna just basically put it right here so we can see both of them. Much easier. Okay, and I'm just arranging those so that we can see everything in one place. Okay, so now hopefully it'll allow me to edit it. Yes, it's allowing me. So I'm gonna do like this is A3. I'm just putting basically a random number in that memory, and this is basically F2 or F3, whatever you want to do. These are, remember, 1 byte hexadecimal, so 56. Maybe FF, and I think that's enough. You can actually clear something or put something else somewhere else. It doesn't really matter. Hopefully the program doesn't touch these, and you can see that actually it's translating all of these to ASCII code. Okay, so it's translating, this is the first byte, second byte, and so forth. But anyway, this is not very important, but I can see what's inside my data memory, and I'm already in bank 0. So now if I want to see how this code is actually running, what I can do is I can say, all right, let us step into this line. I am inside, I'm on this row, which is row 1 of my program memory. Basically my program counter is 0. So if you step through, you probably wouldn't expect the PC to actually jump a couple of steps and implement this move LW to 03. So the command move LW, it moves the number 03 into the working register. So my working register here already have it because I ran that code. But initially, usually it's just 0. Okay, so I'm gonna do that, and you can see that my working directory actually have 03 now in it. I have it just because I ran it. And if you scroll down in here, you can actually see the working register somewhere in here. There you go. So here's the address of the working register. Here's the working register, and here's in red. And it is highlighted in red. It's because this thing has changed. So everything you see in here has changed. So why don't I do the following here? I'm just gonna finish the debugger. I just want to reset everything, and we're gonna clean build it. Okay, and I'm gonna try to do the debugger one more time. I'm gonna pause it. I'm gonna reset it. Okay, so we're back here. This is the program counter, and this is that. And I'm gonna go to the special function registers. Okay, so I'm going to do the same exact thing. So I'm on the first row. I'm going to step into it. So it moved, the program counter moved from 0 to 2 because we're jumping 2 locations. Remember, this is byte address, so I'm jumping a couple of locations because my program memory is arranged as words of 16 bits or a couple of bytes, but they're arranged in a couple of rows. So I jump to the next one. So my program counter has the number 2 in it. And you can see this number 2 here. It tells me, all right, so this is this line in here. It tells me move the working directory content into location 0. Well, 0x is hex is basically 02B. Okay, and this A tells me that you are in the access bank, so you're not dealing with the bank status register or bank select register. And you can see that this one here actually got translated. So my code got translated to the same thing, and that A got translated to access. This is because I'm using the new compiler or the assembler. Okay, I think the older one, it was by default, it wouldn't have had to do this. All right, so now if I implement this particular code, I'm gonna actually see where is my 2B. So of course, because I did reset all of these changes that we made, I actually got reset. So I'm going to do it one more time. I'll pause the recording for a second. All right, so I have changed some locations in memory manually. These are the ones you see in red. And now we are on the second line in program memory. So this second line, if you can read it, it tells me, well, move the content of the working directory to the register that is located in address 2B. And because we're using the A in here, that tells me I am in access memory, so I don't have to specify the bank, but we know it's in bank 0, so it's going to be 02B. Okay, so this is the 02 in here. This is the second row, and I'm interested in B, so which currently have, so 02B is actually this location in here, and currently has 0. So if I press F7, it's going to go through that line and implement it. And you can see that it transferred the content of the working directory or the working register into it, and it's actually now 03. All right, so the next line, which is right here, it tells me load the SFR0 by the address 20, basically 20 in hex. Okay, so technically I want that SFR0, or FSR0 actually, the file select register 0, to actually point to this particular location, which I know it has a 3 right now in it. So I'm going to look at the FSR0. Here's the FSR0. Currently it has that particular number. Once I implement that, I'm going to step through by pressing F7. So F7 in here basically put that 20 inside it. And you can see that in here, it's telling me I have something in location FE9. If it's FSR0, we know the FSR0 is actually split into 2. And that's exactly what happened in here. It put 00 in here and it put 20. But it just, the IDE gives us like just a concise one place where we can look at FSR0 together. All right, good. So now we are in this line in here. We implemented that line, or we can actually take a look at it. It's line 5 on the program, or row 5 in the program directory, in the program memory, sorry. Now we need to move inside here. So this one tells me, okay, we're gonna have an address called repeat. Okay, so the address called repeat is actually in here, which is 008. So yes, I probably have skipped that 3 and 4. You can see that there's no operation in here because the LSFR obviously takes, or apparently it takes a couple of cycles to actually load it, because it's loading technically 2 registers. That's why it's taking 2 cycles. Okay, so now we're here in row 5, and I know the address of this row 5 is 0008. Okay, so it tells me I'm gonna clear whatever that FSR is pointing to, which we know it is this value in here, which is A3. And then it's going to increase the content of FSR0 so that it points to the next one. So I'm going to step through it, F7. So we know this has happened to be 0 now. Looking at FSR0, it has the number 21 in it. So it's pointing to the next location. So it's incremented. So it zeroed it out, and then it incremented the file select register 0. Okay, this is exactly what we saw in the lecture. Okay. So now we're on this line, and this line tells me, okay, decrease the location 2B by 1, and this is what this row means. Okay, well, we know that 2B is in here. It has 03, so once I step through it, it's going to change the 3 to a 2, and so forth. So the last line in here, it tells me, well, branch if not 0. Okay, so you're going to branch if not 0. So here it tells me branch if not 0 to the address of repeat. And if you look at the program directory or program memory in here, it tells me BNZ, which is branch if not 0, to location 8. And this is here. And this is exactly where the clear F. This is what's happening with repeat. Repeat is just a name for where this particular row in program memory is located. Okay, that's good. So branch if not 0. Well, how do I know if it's 0 or not? I need to look at the status register. You can look at the status register. It's probably somewhere around here, but the IDE easily gives us or conveniently gives us the location in here to tell me whether it's 0 or not. So if you see this is the flag, the carry, the digit carry, the 0, the overflow, and the negative. So the 0 is actually small. That means it's a 0. That means the last operation we did, which gave us the number 2 or 02. Was not 0, and that's it. So it's branch if not 0, so it's gonna go back to this row 8. So I'm gonna step through it. So here's F7, and you get the point. So I'm going back in here, and I'm pointing in here. So I'm gonna clear the FF, and then I'm gonna go decrease that 02 to a 01, and then I'm gonna jump back again to clear that 5A. So I'm gonna clear that 5A, and then I'm gonna jump in here. I'm gonna reduce that 00, and now a branch if not 0, you're gonna see that that counter now is 0. This is the counter we placed 3 inside it at the very beginning. So we moved 3, 2, 1, and now I'm at 0. Branch if not 0, well, it happened to be that the last operation resulted in 0. And you can see that the 0 flag, now the Z is capital in the status flag. So it's not going to jump back to the repeat. It's just going to go to the next row, which is 8. Okay, and it goes on and on and on. There are no operations, so nothing will change till it actually goes all the way to the end of program memory, and none of them is actually operating. Okay. Okay, so that was a quick tour of what's actually happening with this particular program. Explore it on your own. So for this week, this is Lab0. And all you have to do is just install MPLAB and run this program. All right.